So today's lesson, we're going to look at the composition of air and the gases in the atmosphere, as well as global warming, and how to measure the percentage of oxygen in air. So quite a few things. To start with, what is actually present in the atmosphere? Well, it is 78% nitrogen, the majority, and not an unreactive gas due to the N2, so it's an NN triple bond. The rest majority is oxygen at around 21%. That makes 99%. The remaining 1% is divided amongst argon at 0.9 as the most abundant, the third most abundant, another noble gas which is unreactive, carbon dioxide at 0.04, and water vapor with other trace gases at around the 0.06% mark. So that is what is in air. Now, to find the percentage of oxygen in air, you can either use a metal or a non-metal. So you can use phosphorus reacting with oxygen to make phosphorus oxide, or you could use copper reacting with oxygen to make copper oxide. So what you have to picture for yourself is that you have two gas syringes. One gas syringe will be with 0 air, and the other gas syringe will be with 100 centimeters cubed of air at the beginning. In between the two gas syringes will be a Pyrex tube that connects them, airtight. Inside the Pyrex tube will be copper metal packed fully. Now, what you do is you heat up your copper with a Bunsen burner on a blue flame. So the Pyrex tube has silica kind of special glass that won't melt. The Pyrex tube doesn't melt. And also there's a special silica tube used on the sides. Now, when you pass the air over, you push the syringe from one side to the other gradually like this while you're heating the copper. And while you do that, the air is continuously passed over the metal. And as you can see in the right side there's the equation. Cu plus O2 makes CuO. That's what's forming. Copper oxide is forming. So the red-brown solid that it starts as, the copper, will be gradually turning black because copper oxide is black. Now, as the copper reacts with oxygen and you keep pushing it over and over, the oxygen is getting removed from the air. So the 100 centimeters cubed will get less and less and less until it should ideally be at 79 centimeters cubed. But what happens is you will know when the experiment is finished because there will be no more red-brown solid left. Everything would have turned black. So unless there was not enough copper to react with all the oxygen, then the reaction should be finished. At the very end, you'll make sure that only one gas syringe has the gas in it. But what you must remember is that the gases expand when they're hot, so the particles move further apart. So once you take off the heat, you can't measure, you can't look at the volume of gas until it's cooled down. If you make a reading while it's hot, then the volume will appear bigger than it is. So say it was supposed to be 80, it might appear at 85, which means when you try to find the percentage of oxygen, which you do by subtracting the final volume from the initial, so 100 minus 85, for example, would be 15. And then you divide it by the original volume, which is 100, you'll get 15%, which is too low. So you cannot make the reading when the gas is hot. You wait for it to cool down, and then the gas will not be expanded and it will reach what it's supposed to reach. So for safety purposes, wear eye protection, and the glass tube will be hot for a long time, so be patient. Don't touch it. And the copper oxide is harmful. So after a few minutes, once the air has cooled down, the volume of remaining air is recorded. So in conclusion, during the heating, the 21 centimeters cubed gets removed. And that's what's actually happening. So for the calculation, you're doing 100 minus the final volume, which is say 80, over the original times 100. So this will actually give 20% as an example, which wouldn't be a bad result because it's supposed to be 21%. Okay, but if you end up with a volume of oxygen which is too high, it means that oxygen is still present. So it means the copper wasn't enough. Not all the copper reacted, so it was an incomplete reaction. Or gases expand and you made the reading when it's hot. Obviously, there could still be possibilities of a leak in the tubes. Now, let us look at the next part. So this part is not important. So in summary here, let's have a look. These are short, discrete answers. Nitrogen 78, oxygen 21, argon 0.9, and carbon dioxide 0.04. The rest being water vapor and other gases, trace gases. Next, on your spec, you're supposed to know what happens when magnesium reacts with oxygen. So, well, it forms magnesium oxide. During that process, there's a bright white light given off. It is highly exothermic. And you form a white powder. So this crumbles and is white. The magnesium is shiny at the start. This is purely memory. The other one you should know about is the sulfur plus oxygen reaction, which forms sulfur dioxide. During that process, the sulfur burns with a blue flame, and you form a colorless poisonous gas. Next reaction is the combustion of hydrogen. So this is an extremely flammable exothermic reaction. Hydrogen plus oxygen makes water. Highly flammable, you get a huge squeaky pop. And then we have a decomposition reaction. So copper carbonate, when heated, will decompose and break down into copper oxide and carbon dioxide. You need to know the colors. So this thermal decomposition starts off with a green solid, which then turns to a black solid. If you bubble the gas that comes out through lime water, it will go cloudy and form a white precipitate. Because the lime water is calcium hydroxide, and when it reacts with the carbon dioxide, it makes calcium carbonate. We will actually revisit this equation when we do chemical tests. The main thing you need to know is that this is green and this is black, and it's a thermal decomposition. Now, carbon dioxide is a non-metal oxide, which, as you should know from the introductory lessons, are acidic. And also, carbon dioxide is a greenhouse gas, so contribute to global warming. We shall look at the global warming in more detail now. But lastly, you should know that the properties of carbon dioxide, they make it useful for fire extinguishers and fizzy drinks. So for fire extinguishers, carbon dioxide is great because it is more dense than air. So it will sink on top of the fire and prevent any other oxygen coming in. Furthermore, it is unreactive with fuels. Remember, oxygen likes to react with fuels, not CO2. The reason it's used in fizzy drinks is that it's soluble in water. So when you bubble the CO2 into the water and dissolve it and close the can and pressurize it, when you open the can, that's when you get the bubbles coming out. Okay, so these were the main points there. Now, the principle with the oxygen is the same, whether you're doing phosphorus or you're doing, whatever you're doing is the same principle. So we're using copper, or using phosphorus is the same principle. So if we have a very brief look at this, you could have a piece of phosphorus here in this glass tube. And what will happen is, as the air gets removed, the water level, for example, will rise up because there's less oxygen. And you can calculate a difference in the rise of the water. Okay, you can even use iron wool because iron reacts with oxygen to make iron oxide. So in all these principles, you will see that the volume at the start is greater than the volume at the end, so the water level moves up. And by calculating the difference, you can see the percentage of oxygen. Now, on to the global warming part then, which will be, I believe, the final part. So global warming, this is how it works. You have the Earth here. You got the sun here. And the sun will release UV light. Here we have the greenhouse gases. What happens when the sun's UV light hits the Earth is it gets re-emitted as infrared. Now, some of the infrared will escape, but a lot of it will also get reflected and trapped back by the greenhouse gases into the Earth, which will cause the Earth to warm up. So it can be a 3-mark question, but this is the principle. Now, UV light is short wavelength. Infrared is long wavelength. The way you can remember it is the word in is shorter than the word out. Out is 3 letters, so it is long. So in, out. In short, out long. You use one or the other. So short, by short I mean short wavelength. This is the physics symbol. Now, I would just prefer to use UV light from the sun comes into the Earth and passes through the greenhouse gases. Infrared gets re-emitted, and some of it gets trapped by the greenhouse gases to warm up the Earth. So if I form an answer here, UV light from the sun passes through the greenhouse gases. UV light is re-emitted. Don't say reflected, you have to say re-emitted as infrared. Some infrared is reflected / trapped by the greenhouse gases, causing global warming. Okay, so that is the principle. I've saved that. I've probably gone into a bit more depth than an Edexcel student would need for the greenhouse effect. But if you do AQA, you definitely need to know these 3 points. Edexcel students, it won't hurt you. If you look at your syllabus extract here, you should know that carbon dioxide is a greenhouse gas and it can cause climate change. Okay, that covers the spec points that we had to cover. And the next lesson will be on the reactivity series. So tune in then.